Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar, Pipes, Pressure, and a Precious Resource, the Engineering Challenge of Aging Water. My name is Zoe Eisel from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. GoToWebinar has recently gone through an update, and you can now add live captions, raise your hand, or react using emojis. After the webinar, you will receive a follow-up email that includes a link to the recording and any other information you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have any questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our Building Technical, Managerial, and Finance Capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application, falling short on project funding, not sure where to start? EFCN is here to help. Use the link in the chat to submit a request and receive tailored support based on your project's needs. And on that note, we can get started. I would like to introduce our presenter for today, Eric Williams, Senior Project Manager at the Mississippi Water Resources Research Institute. Welcome, Eric, and I will go ahead and hand it over to you.
Thank you, Zoe. Good afternoon, everybody. My name is Eric Williams, and I work for the Mississippi State University Water Resources Research Institute. Today, the topic is Pipes, Pressure, and a Precious Resource, the Engineering Challenge of Aging Water Infrastructure. I am a project manager at the university, at the Institute. I have an engineering background. I've worked previously for the State Primacy Agency in Mississippi as a regulatory engineer for almost 17 years. I have a background as a B-class water treatment operator. So I've been around the water treatment game for a while, and the common theme and the buzzword for these days is definitely aging infrastructure. So a little bit about what we do at the Institute. We provide a expertise in water and associated land use problems and serve as a repository of knowledge for use in education, research, planning, and community service. We serve the public and private interest in conservation, development, and use of water resources. We provide training opportunities in higher education where professionals can become available to serve government and private sector alike. We assist planning and regulatory bodies in all the levels, whether it be local, state, regional, or federal. And we communicate research findings to users in a form that encourages quick comprehension and direct application to a water-related problem. One thing we do a lot is we assist state agencies in the development and maintenance of a state water management plan. Um, we provide a list of technical services. More what I have done here as of late is provide the list of technical services here. We do comprehensive system evaluations where I will go in and sit down with a drinking water system or a wastewater system and kind of we'll go through from start to finish on whether it be treatment, whether it be rates, whether it be bylaws, any kind of paperwork issues, and we lay out a plan and help the system prioritize where to put their efforts. One other thing we do is water audits. We can help a system figure out how much water they're losing on a monthly basis, a yearly basis, to figure out the best course of action to correct that and get that water loss down. We provide financial rate analysis for systems that haven't increased their rates in a while. One thing in Mississippi that seems to be on the rise is the need for rate studies. With inflation and the high cost of everything from chemicals to electricity to everything, water systems are in dire need to increase their rates these days. We do cross-connection control program assistance, treatment optimization, whether it be chlorination, iron removal, DBP issues. We do compliance consultation. With my regulatory engineering background, I can help systems work through issues with the groundwater rule, total coliform rule, lead and copper rule, surface water rule. I try and just help any systems where we can. We do asset management assistance, distribution system optimization, and chemical feed dosage optimization, and a little bit of everything in between. So on this side of the institute, we will help water and wastewater systems however they need help. So quick overview of the presentation. We're going to talk about the state of the rural water systems and municipalities in 2025, the key challenges that water utilities are facing. We're going to explore some viable and economical solutions that they can take to mitigate these problems with the aging infrastructure, the role of leadership that plays in this, and why and reinvestment can't wait, in asset management and education, and how we can move forward to solve these problems. So a little backstory and context on what we do in Mississippi. We are by far a majority of groundwater systems. We have, I believe, 4 or 5 surface water treatment plants. And those, there's 2 or 3 in the very northeast corner of Mississippi, and then obviously Jackson, Mississippi has the largest surface water treatment plant. That is the city with the largest population in the state. But a majority of the systems in Mississippi are what EPA would consider small or very small systems. Whether it be 1,000, 1,500 or less. And generally, most rural systems are anywhere between 100 to 500 customers. So very small systems and lots of them. There's approximately 1,200, give or take, public water systems throughout the state. And most of the rural systems were established in the 1970s through the FHA loan programs. So this, the context of this presentation is obviously geared towards Mississippi. It can, apply to across the nation, but my background is here in Mississippi, so that's kind of what we're going to focus on. So in Mississippi, the water quality and quantity can vary greatly across the state. We have some systems that their treatment involves liquid chlorination because they have 50 customers, and then you have some systems who have 20 parts of iron, in the groundwater, and it's a lot more labor-intensive treatment. So your treatment techniques can be very labor-intensive and have a high capital cost. So the upgrade process is very lengthy when you're talking about completely rehabbing a iron removal plant or ion exchange plant, reverse osmosis, something like that. The planning, design, and engineering, regulatory review, construction, all of those take anywhere between 2 to 5 years, I would say. So it's not something that you can just up one day decide, hey, we as a system need to build a new treatment plant. It's a very lengthy process and can take some time, and then the operation takes a while to get used to also. So when we're talking about aging infrastructure and how it's a growing concern, you're looking at a large percentage of the treatment plants and equipment are past their design life. One thing I see when I'm in the field pretty regularly is just water wells, service pumps, chemical feed pumps, all of the equipment within a treatment plant, and that's just within a treatment plant. Those things are well beyond what most manufacturers would consider their design life. Now, over time, a water well yield will decrease, based on the screens. They'll become stopped up and over time. Uh, you know, pump life is not what it used to be in some cases. Uh, the upgrades on the treatment plants can be restricted because of limited revenue. Like I said earlier, a lot of systems have really fallen behind on their rate structures. So they are in the process of getting rate studies on a routine basis, and they have to implement those rate studies in order to make enough revenue to keep up with the growing problems that we're facing in the industry. Another thing is they're struggling to meet modern regulatory and operational demands. There's new regulations coming out annually, and it's a lot more intensive treatment than we may have had 30 years ago. So some of the key problems that I see in my line of work are aging treatment plants. That's what we can see. Pump facilities, those are obviously right there with treatment plants. Water quality degradation, whether it be because of distribution or storage, or the treatment itself. Distribution system deficiencies. When you're talking about water age and the water quality throughout the system, it's all based on the treatment and how long it sits in the distribution, and how can we go about to solve these problems. One of the biggest things that I see is antiquated electrical components. Most of these rural water systems that were formed in the 70s and 80s have honestly not upgraded their electrical components since then. And so a lot of them are falling behind, and they have issues on a daily, weekly, monthly basis with electrical problems, to where they're having downtime, and it's just causing major headaches. Sanitary defects and contamination risk. Once the infrastructure throughout the system gets as old as it is, you start having problems with sources of contamination entering the system. Operational and customer impacts. I would say one of the biggest issues in Mississippi that we talk about these days are customer relations and the aging workforce. So we'll talk about these things. So some of the technical challenges and solutions, like I said earlier, a lot of these water systems are operating beyond their intended design life. They were never designed to last 60 years without major upgrades. So they're starting to pose risk to water quality, system reliability, compliance, and public trust. One of the biggest pushes over the past couple of years is the revisions to the lead and copper rule has forced a lot of systems to do this lead service line inventory. And not only does that bring awareness to service lines, but it brings awareness to the distribution in the water systems. So a lot of officials for these water systems, officials and operators both, have began to take note of what's in the ground, and now that they can see it on paper, it's really bringing it to light on how old stuff is and how in bad a shape it is. So it's bringing a renewed attention to the issue of the aging infrastructure. Um, some of the limitations, these treatment facilities were designed for water quality conditions that may have been, you know, uh, from the 1960s, 70s, when they were designed. The regulatory standards were lower then. The system demands were lower. One thing I see in the field a lot is water systems. They were designed for 200 or 300 customers, and they kind of piecemeal it together in order to serve the 11, 12, 1,500 customers, and it just can't keep up because so much of the infrastructure throughout the system was designed for smaller demands, and so we're running into big problems there. Structures such as sedimentation basins, elevated tanks, concrete tanks, hydropneumatic tanks, and other equipment, uh, they all increase the failure risk of the system. Water quality compliance risks. When you have treatment that is not reliable, whether it be from filter media, whether it be from chemical feed pumps, whatever, at the treatment plant, you're going to impact your turbidity removal, iron or manganese removal, disinfection effectiveness, disinfection byproduct control throughout the distribution, your optimization control, and without redundancy, you're increasing your vulnerability during equipment failures, during maintenance activities, system outages, chemical process downtimes. One thing I see more than anything is no redundancy on these small systems, and we can't preach that enough that these systems have redundancy, whether it even just as simple as a chemical feed pump to have a backup. These systems have got to get the redundancy in place so there is no downtime. Some of the operational challenges: you have obsolete equipment and controls, and those limit your process optimization, your water quality monitoring. You can't collect data properly. Uh, without those things, it's hard to track what your treatment plant is doing. It's hard to keep track of what's going on in distribution. So we really need to have more up-to-date controls put in place to where you can properly monitor those water quality parameters throughout the system. Uh, when you increase your reliance on your operator intervention, it increases operational risk. So it's more room for error. So the more an operator is in the treatment plant making changes to equipment, the more room for error that arise. Mechanical and electrical deficiencies. Your pumps and motors are, like I said, pumps and motors are operating well beyond their expected service life. Uh, Increased likelihood of mechanical failure. Seals and bearings are going to go bad. Your electrical and control systems are going to fail. Some of the hydraulic and pressure impacts you see throughout these systems, where you may have 10-inch line that goes to a 6-inch line that goes to a 4-inch line. You're just going to have a lot of pressure fluctuations, and eventually, when you start adding more and more customers to these systems in places that they cannot handle it, you're going to have low pressure events, and during peak demand, you're going to have outages or major impacts. And when you overload these systems, it's going to lead to the friction loss, which is going to lower the pressure overall, and ultimately you're going to lose your consumer confidence because people are going to be calling the system itself and complaining on a regular basis. So your hydraulic and design limitations, when you're talking dead end water mains and unlooped lines, it's going to cause stagnation, poor water quality, and increased flushing and maintenance costs. Uh, the aging pipes increase your leakage and break frequency. So there's a lot of systems. I know the system that I live on here in DeSoto County, Mississippi, is it's kind of 3 or 4 water systems that were consolidated over time. So you have a lot of old water lines throughout the system, and I think there's a running list of about 200 or 300 leaks every month. So they have to prioritize which ones are worse to fix first. But it's a dedicated crew that they work on these water lines on a daily basis just because of the age of the water lines in the ground. Water quality contamination risk. Obviously, your pressure losses are going to increase the risk of contamination intrusion, backflow events. The aging pump stations, they may lack controls and backup power, alarms and monitoring capabilities. So your water quality degradation. We talk a lot about water age management. When you're talking about DPBs in the system, loss of disinfectant residual, carrying a free chlorine deep throughout the distribution system. With the aging tanks and poorly mixed tanks, these issues will definitely worsen. Your operational control limitations. So when you cannot control where the water goes or where it stops, you have to take the whole system offline. And there's many systems throughout our state that they're small, but they still have to take the half the system or maybe sometimes even the whole system offline in order to fix a leak. So what we have recommended is when we go out and we do some system mapping or do these comprehensive evaluations, we'll recommend areas where you can put control valves in order to help isolate certain areas so you can fix leaks and have repair zones and lessen your contamination events. Sanitary defects and contamination risks. From a regulatory engineering standpoint, I always think about significant deficiencies and sanitary defects in the aspect of, at the treatment plant, when things start to degrade to a point to where you have open holes in storage tanks and things like that. You're just opening these pathways for contamination, whether it be from animals, bugs, whatever, chemicals, it can be anything. So we really have to look at how we can stay on maintenance schedules to keep these issues from arising. So these vulnerabilities at the treatment plants and source water connections, that's kind of the place you would see them the most. Obviously, when the water lines are in the ground, as long as they have pressure, it's a lot more it's a lot harder to have the backflow events unless you lose pressure. So EPA has a table here that kind of gives an idea of the life expectancy of certain components throughout the water system, and I've put some of them on this table. So when we're talking about water wells, the life expectancy is about 25 years. Now, that doesn't mean you have to drill a new well in 25 years, but that means 25 years you need to be planning to drill a new well after that, or plan to rebuild the existing well. And intake structures is 35 years. Pumping equipment is 10 years. Disinfection equipment, 5 years. Tanks, whether they be hydropneumatic, concrete, metal, they can be anywhere from 10 to 30 years. Piping and valves, You're looking at 35 years. Controls and software, 5 to 20 years. When you're talking about electrical components and software, you can kind of think back 20 years ago. I would venture to say most of us were still using flip phones. So look at how far that's come since then. So there's a lot to be said for the controls aspect of a treatment plant. It's kind of an evolving process every day. Zoe, can we put the first poll question in? Did it show up?
Yes, it's in process right now. About 25% of folks have voted.
Okay.
We'll give
Yeah,
some people time to.
we'll give them a minute here. You just let me know when to proceed.
Looks like the majority of folks have voted. We've got about 51% of folks saying reliable infrastructure, 27% of folks saying financial planning, 17% of folks saying SCADA, and 5% of folks saying customer communication.
Okay. So obviously, a big one is reliable infrastructure. Now, the question is, what do you consider most powerful tool in managing and operating a public water system? It's not really a trick question. It can be any of those. A good SCADA system is always going to be very helpful to monitor and operate your system. Reliable infrastructure has to be in place in order to operate the system. Financial planning is definitely important, but one thing that hits close to home for me is customer communication. Um, with social media the way it is now, you almost have to be communicating with your customers on the front end rather than the back end just about every time. Operational customer impacts. We're talking boil water notice, emergency shutdowns, service disruptions, compliance-related violations, and poor customer communication that can erode your public confidence during these kind of events. So, in my mind, customer communication is a very big role in operating a water system. Not only you can have the best system in the region with all the bells and whistles, but if you don't have good customer communication, it's never going to be run efficiently. So, that's good question there. When we're talking about these things, so the consequences of inaction in this situation, you're going to have continued regulatory challenges and enforcement actions. You're going to have rising maintenance and emergency repair costs, loss of institutional knowledge as experienced operators retire, increased public health risk and customer dissatisfaction. So with all these things that we've talked about, the what it boils down to is just a failing business. Essentially, you have to manage this as a business. So some of the solutions to address are infrastructure improvements, how we can make those, water quality and compliance strategies, planning, prioritization and funding, workforce and knowledge transfer, and customer and stakeholder engagement. So when you're talking about treatment plant upgrades, the biggest thing we need to do is modernize treatment processes to meet current and future regulations. I think it's obvious with everything that is coming these days. we need to be ready for any future regulations that may come. Be flexible with how our treatment is, but at the same time be very efficient. So we need redundancy for these critical treatment components. Whether it be service pumps, chemical feed pumps, we've got to have redundancy and upgrade monitoring controls and automated systems. Your monitoring controls is what's going to save you. You have to have the data to back you up to know what changes to make throughout the treatment plant. Pump facility improvements. We can replace the aging pumps and motors with energy efficient units. Variable frequency drive motors have saved a lot of systems a lot of money by installing these on wells, service pumps, whatever it may be. They just they run when they need to, and they use a lot less electricity. We can improve pressure management and system reliability. We can add backup power on some of these treatment plants that may not have generators. SCADA and alarm systems can be put into place, and redundancy for critical pumping facilities. Storage and distribution improvements. We can always loop distribution lines and eliminate dead ends. Some systems, it's inevitable you can't do that, but if there is a way to loop some dead ends and get rid of them, that is going to save your water age problems throughout your distribution. And when you're doing these things, you can always add strategically placed valves to improve your isolation capabilities and reduce your service interruptions. We can upgrade storage tanks and install tank mixers so we improve the water quality and reduce the water age. The coordinated infrastructure upgrades. One thing I'm seeing more now is coordination, especially for municipalities. When you have a road project, it's a good time to relocate and upgrade water lines, sewer lines, broadband. That when you're doing them all at once, it can reduce construction impacts, disruption, cost of overall. Dig once policy. Some municipalities are putting policies into place where you install conduit under roads and in certain places, so there's minimal disruptions down the road if you had to fix a leak, or if a broadband or internet wants to put new lines in, they go through this conduit. Water quality compliance strategies. Implement proactive water age management programs. And that can help address the DPV formation throughout the system. System design improvements, optimization. I can't say enough for optimization. I think every system, whether they've been an operator has been there for 5 days or 5 years or 15 years, I think every system should do a periodic optimization review of their treatment facility so they can just fine tune it to make it work in the most efficient manner it can. Prepare for and educate systems on upcoming regulation requirements. Mississippi does a pretty good job throughout all the training programs, educating water systems on upcoming regulatory requirements. And I like to think that we are here to help them get everything in order and get ready and make all the resources available to them that we can. Some other paths forward. We can invest in efficient treatment technologies, like we said, well motor VFDs. We can use smart metering technologies, continuous chemical monitoring. Always, like I've been saying this the whole time, is upgrade electrical components, distribution line looping, fire flow, hydraulic models. I encourage just about every system I come into contact with to have a working hydraulic model that is continuously updated and reviewed. Automated metering, whether it be master meters or residential commercial meters. let these systems see what's going on in real time, so they can make changes where needed. So planning, prioritization, and funding. So we can help systems by assessing treatment, pumping, and storage and distribution assets, and identify what critical needs they have. We can help them prioritize projects based on the risk and consequence of failure. And we explore partnerships and consolidation opportunities to improve resiliency, share resources, and reduce long-term costs. We have partnerships with lots of systems. There's several organizations that help, similar to the way the Institute helps these systems, and these partnerships help water systems get funding. We put them in touch with the right people. We essentially facilitate their needs, so we can put them where they need to be to get these projects done. And the consolidation, the one thing with Mississippi is, as I've said earlier, there's a lot of systems and a lot of small systems. So it may be beneficial for some of these systems that only have 100, 200, 300 connections to consolidate with a neighboring system that may have 100 connections. And you can reduce that long-term cost by spreading the cost of a certain project across all the customers rather than just one system at a time. We can always increase outreach to identify and pursue funding opportunities, whether it's grants or low interest loans. All right, Zoe, let's do the other poll question now, please.
All right, just got that launched. We'll give some people some time to respond.
All right, we'll give them a couple minutes.
All right, it looks like the bulk of folks have voted. It seems like 55% of people think 54 years, 30% of people think 48 years, 9% of people think 63 years, and 7% of folks think 35 years.
All right. Well, the Mississippi State University Extension Service, we did a study, I think in 2023, that came up with the median age of a water treatment plant operator. Now, this is in Mississippi, so once again, context. 54 years old is the average age of a water treatment plant operator in the state of Mississippi. So, that's not old, but it's not young either. And there's really, I think we're going to see the effects of the aging workforce over the next 15 years. So, I think it's important that we as an industry begin recruiting water treatment plant operators and professionals into this industry, on a annual basis. So one thing we really need to do is address the aging workforce, and that's by creating avenues for knowledge transfer from experienced staff. I know we all know water treatment plant operators that have been at a system for 40 years, and when they retire, they take all that knowledge with them. And it's not necessarily just knowledge about the treatment plant, it's the knowledge about the distribution, where valves are, where certain houses have certain pressures. It's just a plethora of knowledge that's not written down anywhere. It's not put on paper. So one thing we're trying to do is to put those things on in some kind of database and transfer this knowledge from experienced staff to the next generation of operators. So, I know there's an organization in Mississippi Rural Water Association. They have a apprenticeship program, and that has gone over very well. And they facilitate younger operators uh, working with mentors and getting lots of knowledge on how to effectively operate a water system. So we can always support the training and mentorship of the next generation. Another thing that we can always get behind is standardize the operating procedures and documentation. If everybody's doing it not exactly the same way, but some semblance of the same way, then we can all expect similar results. And when you compare the data, it all matches up evenly. So funding opportunities, the EFCN has done a great job with compiling information. If anybody ever needs to know what kind of funding opportunities are available in your state, you can get on the EFCN website, and they have, I think it's an interactive map. You can click on your state, and it pulls up funding tables similar to this one. This is just a screenshot that I took of Mississippi for water related funding. And there's obviously more than just this one, but this shows like the Mississippi State Department of Health. They have the SRF program, and it gives the contact information, website links, how to apply, and the purpose or use of funds. So it's a very useful tool that has been put together by the EFCN, and I've used it several times. It's been very helpful. Education, when you're talking about education, you can't have enough education, whether you're an operator in training, an operator, seasoned operator, board president, engineer. It doesn't matter. The more education opportunities you have, the better. And we always encourage staff and leadership to have continuous training and stay current with the regulations and technologies, and to foster a culture of professional development. So the role of the leadership throughout the systems that really drives this business is to manage it as a business. You have to have it managed as a business, and not just a charity case. Because I mean, you cannot put money back into the system without making money. So we have to have proactive planning. We have to have system evaluations. You have to do growth forecasting. I know there's several examples of systems throughout my area that have grown, maybe 600% over the past 10 years. Just certain pockets throughout the state that have grown leaps and bounds, and the infrastructure can't keep up. So we have to have that sort of forecasting. We need gradual upgrades. These systems, they should be doing gradual upgrades on their own on an annual basis. It should be a rolling process. Regular optimization reviews, we talked about that earlier. I think every system should go through a treatment plan. I think they should go through the distribution system and do whatever kind of optimization reviews they can, use data and research to compile a plan to optimize the treatment so the water quality is the best water they can serve their consumers. Rate adjustments, everything has to run through with money, so rate adjustments need to be tied to the needs. They need to be increased generally annually. Customers and stakeholder engagement, strengthening your customer communication before, during, and after infrastructure projects. Clearly explain why the upgrades are needed, how customers benefit, and what to expect during construction or service disruptions. Some small systems, they can have a system-wide meeting. I know a lot of municipalities use social media to inform their customers of what's coming, and how long it's going to last, and what's purpose it's going to serve, and how it's going to better the system. I think that goes a long way with your customer relations. The role of collaboration. You have partnerships like us at the Institute. We will partner with a system and help with project financing, help them get funding through one or multiple sources. We will help with technical assistance and regulatory navigation. Consolidation and regional cooperation can enhance the operational efficiency, compliance, stability, long-term system sustainability. We talked about that earlier, where you have certain systems. I know there's an entire county here in Mississippi that connected. I want to say it was about 6 rural water associations back in the 90s, and it's a very well run system now. It's one entity running those 6 systems that are connected, and they don't necessarily have to be physically connected. If they're all consolidated and run by one managing entity, it just spreads the overall cost of things over all of those customers, and makes it a little easier to get things done. Consolidation, combine small systems to share your resources, expands your base and your revenue, and it lowers the per unit cost of operations. You need to reinvest now to ensure long-term viability. I have not seen many things get cheaper over time, so it is best to plan accordingly and act on problems you have. Act on them now. Combine smart planning and technology and leadership, and it will ensure safe and reliable water for future generations. So asset management is one of those things that it's a hot topic these days, and I highly encourage the systems I work with to have a good asset management plan that is very detailed. You start small and work your way into more detailed plan. But it'll maintain the inventory of all your assets, and it'll track the condition and age and the life expectancy. It plans for a timely replacement, and it ensures efficient, reliable operation of the system. By seeing these things in front of you, and seeing the data, it makes system officials that much more aware of what's going on and what's needed, so these systems can get what they need. So in conclusion, building a resilient system for the future. Aging infrastructure is definitely a challenge, but it's also an opportunity. An opportunity to work together and help systems throughout your state, region, country, whatever, to understand the proper steps that need to be taken to get where they need to go. So strategic investments in treatment, pumping, storage, and distribution systems are going to protect the public health, improve compliance, reduce service disruptions, and build a resilient system for future generations. Is there any questions or discussion? I'll hand it back to you, Zoe.
All right, I'd like to encourage attendees to put their questions into the questions chat, but we do have a couple that have already started. So the first question will be, a while ago, a student checked the Bureau of Labor Statistics. BLS showed utility operator as a shrinking profession with low salaries. That could drive young folks away. Can we work to change that?
I believe so. As I mentioned earlier, Mississippi Rural Water Association here in Mississippi, they have an apprenticeship program, and I've really seen good things about that. It puts younger operators with some more seasoned operators to really share the tips and the tricks of the trade. And I think one other thing we've talked about in the past is how we can implement operator training, whether it be in community colleges, whether it be in high school, vocation technology classes. We really need to do a better job at outreach, as a whole in the industry, to let this younger generation know that the opportunity is there. The younger operators, I mean, they can can set their pay rate because it's just uh, the industry as a whole is losing so much of its workforce on an annual basis that it's a high demand, that's for sure. So I definitely think there's ways we can do better outreach. I don't think we've had to until maybe the last 10 years, but I'm definitely seeing it here in Mississippi.
Thank you. Our next question is, can you please expand on the optimization process or procedure for water systems?
Yeah, so mm, that one's kind of near and dear to my heart. When I was working for the primacy agency in Mississippi, I was part of a program that EPA had called the AWOP program, it's Area Wide Optimization Program, and I think each region has one throughout the country. And we would go in and find ways to optimize just about any kind of treatment plant or distribution system that you could. And we would meet 2 or 3 times a year. And it really opened my eyes on the ability to optimize a treatment plant, distribution system, and data integrity. Lots of opportunities there to start to finish. I mean, you figure out what your source water is, you figure out what your treatment is, and you start pulling samples and get data all throughout that treatment plant. You take that information, you compile it, and you brainstorm on how you can better treat that water to send better quality water in the system. And same thing in the distribution system is it's all about data. So the more data you have, the better.
All right, thank you. Our next question is, do any states require asset management plans of all public water systems? Do we know what % of public water systems have an asset management plan?
I can't speak for other states offhand, but Mississippi, it is I'm not going to say a requirement, but it is to to get a point on the capacity assessment, you have to have an active asset management plan. Most systems, if they don't have one, they're working on one. And that's one thing we at the Institute are doing. I know Mississippi Rural Water Association is helping systems put plans together also. Uh, like I said, it doesn't have to be a super detailed asset management plan, but it needs to have something. I mean, if you have 3 wells and 2 tanks, I mean, that's your major assets you have right there. A major asset is all the pipe in the ground. So those are things that you know offhand, and you know how old they are. It should be pretty easy to compile. But as far as requirements, I know to get certain funding, you have to have one, and I know in Mississippi, it's pretty much required.
Thank you. Our next question is, can you identify some of the most recent regulations or limits that have made meeting wastewater requirements difficult for small systems?
Wastewater. Um,
Yes.
I'm gonna say phosphorus is probably the biggest change, and I'm not very well versed in wastewater as much as water, but from people I know in the industry, they've had to uh, really change up how their wastewater treatment plants are. And some of these small systems, it's really hard to get the funding to upgrade these plants for how stringent the reduced limits are. So uh, I'm going to say I'm not 100% sure on that, but I know the phosphorus limits being lowered over the past several years has been a big hindrance in this area.
Thank you. Our next question is, do you have any problems in Mississippi with PFAS in the groundwater supplies?
So I haven't looked in probably 6 or 8 months, but there was very few, if any, groundwater hits on PFAS or PFOA. We have a surface water plant in northeast Mississippi that's downstream of some industrial discharge that that tested higher. And I want to say maybe there was one or two groundwater wells that had some higher levels, but not anywhere close to what surface water would be. And we're very blessed in Mississippi to have an abundance of groundwater. So in situations where you may have a well that tests higher, generally I think they can just turn that well off and just not use it. So I mean they're actively sampling for that. I have not seen the numbers in a while, but uh, we have not, thankfully, not had any major issues with those contaminants in the groundwater.
Thank you. Our next question is, what would be the best strategy to implement real-time pressure monitoring and acoustic leak detection in the distribution system?
Oh, I'm going to say you could put pressure transducer or pressure monitors, in different areas throughout the system. I'm. Can you repeat the question again? Sorry.
Sorry, I just removed it, but the
Oh, well, that's
question,
fine.
okay, sorry about that.
No, it's fine. I mean, as far as actively measuring the pressures throughout the system, I mean, you're going to put pressure. What I have done in the past is put pressure monitors and uh, in strategic areas, and you can kind of tell where you're having issues. But as far as acoustic monitoring, I'm not well versed in that, so I can't really speak on that.
Yeah, no worries. We'll transition to this next question. When conducting asset management plans, what tools do you use for condition assessment for underground assets such as pipes?
Generally, you're going to rely on the the aging workforce to know when it was put in and what material it is. If you don't know that, usually there's some record of a leak being fixed in that area. And what we try and encourage systems to do is to record those materials when they fix it. That way, they know what's in that area. Whether it be a 6-inch ductile iron pipe or a 6-inch HDPE, whatever. And that's going to be your best course of action of knowing what's in the ground. But generally, there's usually somebody that was there when it was put in, so they know kind of what's there and how long it's been there. And we've been really blessed in Mississippi to have good engineering records and as-built plans, and so you can usually go back and look at those and get a good idea of what's in the ground.
Thank you. We'll try to squeeze one more question in. Let's go with, have you seen any success stories in small systems voicing their regulatory concerns and the regulatory community responding?
I'm going to say yes. Uh, you know, we've had several very small systems in this state that have, more or less come to the table with the Department of Health and said, we can't meet that requirement realistically. We don't have the money. So generally, in a situation like that, it's never oh, well, that's not our problem. It's the Department of Health does a great job at sitting down and trying to find solutions. I was actually in a meeting yesterday with a system that's doing something similar. So we put everybody's heads together and try and figure out a good solution for funding of how we can mitigate a problem, and and it usually works out well. A lot of times it ends in consolidation with a neighboring system. Because let's be real, I mean, when you have a system that's got 80 to 100 customers, and you're trying to install a reverse osmosis treatment plant, I mean, the financials just don't make sense. So the best thing to do is to join two systems together and spread that cost over the majority of the customers. So that's kind of what we've done in the past.
Thank you for sharing that. And I'm going to go ahead and begin to close this out. Huge thank you to Eric for sharing his expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar so that you can let us know your thoughts on today's session, as this helps us plan future webinars on topics important to you. Thank you again, and we hope to see you at future EFCN events.